In the last lecture, we are discussing about fuzzy relation, and there are few portions remaining. So, I will start with that remaining portion, and then finally, I will go to the another concept of fuzzy, it is called the fuzzy proposition. So, the fuzzy relation that we have discussed, as we see, it is called the binary fuzzy relation. Binary means it is a relation over the two fuzzy relation. So, that is why binary or the union, intersection or the composition, they are binary fuzzy relation, other than the complement, that is the intersection, it is the complement of the fuzzy relation is a unary fuzzy relation. Now, such a fuzzy relation can be also graphically displayed, and that graphically it is look like. So, mu x y is basically the membership values of the relation, and if we plot in a 3D graphs, then the graphically representation it will look like this, is this kind of form, like that means the membership function how varies. So, the graphical representation can be plotted with some mathematical tools like MATLAB, if the two relations given or the fuzzy the sets are given and all these things. So, sometimes the mathematical operations and using some tools we can pictorially describe different relation or operation to understand how system works. Now, I want to discuss about this binary fuzzy relation with some mathematical meaning in it, and here is an example that I want to show. This example you can check it carefully. So, x and y, x is a fuzzy set which is defined like this over the universe of discourse R, that positive, there is basically positive values or positive numbers, and R is the another relation which is defined over the discourse x and x cross y, where y is also another relation is defined over the set of positive numbers, and the relation x is basically or y, it is the relation is defined here that y is much greater than x. The membership function of such a relation can be defined more mathematically using this formula, suppose. Okay. So, is a much greater than, it is discussed by this relation, and if it is y is greater than x and if y less than x, then it is 0. So, this basically gives the membership value for a relation between x and y is an order pair in the relation, and it can be depicted in the form of a matrix. Now, here an example. So, x is a set, y is another set, and if we follow this relation, then the relation matrix that can be obtained like this one. So, this is basically is another way of representing 2D membership function, is a binary function also, other than the max min composition that we have discussed. So, there is a many interpretation that can be applied, and then fuzzy relation can be obtained. Now, after this fuzzy relation is known to us, okay, this is another implication of the fuzzy relation. So, basically A cross B, if is a fuzzy relation, as you know that is basically says a relation that if it belongs to a particular relation, then what is the strength. Now, I can say one example here. See, if x is A or y is B, then z is C. So, this kind of concept can be expressed by means of two product, like, see, if x is A, then z is C, it can be represented by means of the product, Cartesian product of the two set A and C. So, this gives a relation R 1. Similarly, if y is B, then z is C, it can be represented by the Cartesian product B and C, and this is a relation R 2. Now, so a Cartesian product between the two fuzzy sets results a relation, and a relation takes the form like this. If x is A, then z is C. This means that how x and z is related, or the relationship strength between x and z, which belongs to the set A and set C likewise. Now, if here this is another example, if you see, if two relations are related, then what will be the result in this one. For example, if x is A or y is B, then z is C, how it can be represented. So, it is basically if x is A, this is another relation, y is B, then another relation. So, it gives Z is another relation. So, if the two relations are given to you by this form, so this kind of expression can be obtained, that this is the relation R 1 or is R 2. So, union. Similarly, if I say if x is A instead of OR, it is AND, then that relation can be obtained by intersection this R 2. So, this basically shows some application where the relationship is used and they can be applied. So, the operation that we have discussed there we can apply, and then we can find other relations as well as this one. Next, we will discuss about another important elements in the fuzzy system, it is called the fuzzy proposition. So, exactly what is the proposition? Proposition basically one statement. So, statement like sun rises in the east. So, it is a proposition. What is the truth value? Truth value means sun rises in the east, its value is basically either 0 or 1 or true or false. So, it returns true. Similarly, the many propositions can be given. For example, the mango is sweet, it is a proposition and it can result any value, sweet yes, no, or may be sweet, may not be sweet, or these kind of things are there. So, proposition not necessarily give only two value, either yes or no or true or false, it can give any value. So, in case suppose it gives only two values, then we say it is a binary proposition, or binary proposition is also sometimes called the predicate proposition or simply the Cripps proposition. Now, the fuzzy proposition means that truth value, that means the value of a proposition that is possible, not necessarily only two values, it can be two or more values. So, let us see how the fuzzy proposition can be defined and how it can be applied in our fuzzy system, and what are the different operations those are possible in order to have the fuzzy proposition more meaningful implication or significance. Now, fuzzy proposition is basically as okay. So, fuzzy logic in fact is called the multi-valued logic, in contrast to the Boolean logic is called the two-valued logic. So, this is the one difference between the Cripps logic or fuzzy logic or Boolean logic or fuzzy logic. So, Cripps logic or Boolean logic, they are basically two-valued logic, whereas the fuzzy logic is basically the multi-valued logic. Now, so exactly this is the important difference is there. Now, in this discussion, in the coming discussion, we will first learn what is the difference between two-value logic and then multi-value logic, or how the two different logics are related, and then we will discuss about some examples on fuzzy proposition, and then we will try to find the difference between the fuzzy propositions and then Cripps proposition, mainly the Boolean proposition or predicate proposition, and then we will learn about how to represent a fuzzy proposition. This kind of representation is called the canonical representation, and the graphical interpretation of a fuzzy proposition. Then now, let us start about the discussion about two-value logic versus multi-value logic. As I told you, two-value logic basically based on the two values of the logic. The two values are namely true or false, sometimes it is represented 1 or 0, yes or no. So, whatever it is there, only two values. Now, the classical two-value logic, in fact whatever the concept that is applicable to two-value logic can be extended to multi-value logic. Now, it is interesting to note how this extension can be taken place in case of multi-value logic, namely say binary logic. Now, for this illustration we will consider multi-value logic in terms of three values: true, false and indeterminacy. That means, in between 0 and 1 it is say half. That means, a logic can be defined whose values or outcome can be in terms of any three value 0, half and 1. So, having this is the composition. Now, let us see how the multi-value logic can be defined using the conventional two value logic operation. Now, conventional two value logic operation, we say it is the AND operation OR operation. AND operation is very similar to the intersection operation, the OR operation is very similar to the union operation, and this is the operation called the complement, and this is the implication operation, and this is the equal operation. Now, if you know Boolean logic, then you will be able to understand how the AND operation of two Boolean variables can be applied, or a complement of a Boolean variable can be operated. Now, here for example, if A and B are the two values for the two variables A and B, then its AND operation is 0 and then OR operation is 0, complement is 1 and this implication is 1. So, implication is basically, see, A implies B is equivalent to A complement or B. So, it is the general expression, this is basically same thing, A implies B is equivalent to A complement or B. So, this is borrowed from the Boolean logic. Here for example, A complement means 1 or B 0. So, this is why this value is 1. Now, let us consider, so these are 0 0, now here 0 and half. Now, likewise the AND operation is basically 0 and half, we have to take the minimum. So, AND operation is minimum. So, this operation gives the result 0 and OR operation is taking the maximum 0 and half, the maximum is half. So, it is half, and then complement means A complement. So, it is this one. If we take the B complement, then you can understand what is the result. B complement will also result half, because it is 1 minus half, and A implies this and can be obtained using this formula, you can obtain this one 1, and A equals B, it is half, this kind of things it is there. So, these are the table that can be applied for the different operation, namely AND, which is equivalent to intersection, or union is a complementation, and implication and equal are the two special operation that is there in case of Boolean logic. Now, these are the operation that we can have, that this is the truth values for the three value logic, and three value logic is very closely related to the concept of multi value logic. Now, I can a little bit move forward to indicate the different operations that can be applied in terms of proposition. Now, here for every proposition have some truth value. If we denote this proposition as a TP, say suppose P is a proposition, and TP denotes its truth value, then the complement of this proposition is basically 1 minus TP. Now, or if two proposition P and Q and their truth values TP and TQ known, then P and Q, the union operation of the two propositions, can be expressed using this formula, is a max. That means, maximum of the values of TP and maximum values of TQ gives the result of the, this is basically TP truth value of the P or Q. Similarly, two proposition P and Q, if we apply the intersection operation which is defined by this expression, then we can give this is the truth value of this operation. Then implication, it is I told you P implies Q, equivalently not P or Q. This can also be alternatively can be observed that it can give this one. So, it is max of 1 minus TP and TQ. Now, equality, the P equals Q, it can be defined alternatively P implies Q and Q implies P, which alternatively can be obtained using this formula. So, what I want to say is that the propositions are there, propositions may have two valued, three valued or multiple valued logic, and then there are operations, different operations, these are the different logical operations, symbols and then whatever the meaning, and that can be applied and can be obtained using this kind of definition. Now, let us see some example, so that we can understand the concept of proposition more clearly. Say one proposition, this Ram is honest. Now, Ram is honest. having this proposition can have many truth value. So, Tp 0.0, it is basically in terms of fuzzy logic. That means, if we draw a fuzzy sets that RAM is honest, then the membership function take this value, it is like this. So, according to the different elements, it can be obtained like this. So, it is basically the different truth value that is possible. RAM is honest, Tp 0.0, 0.2, 0.4, whatever it is there, meaning that is absolutely false, is a meaning that it is absolutely false or partially false, these kind of things here. So, that means P is a proposition and this proposition may have different values, that we can say the different truth values there are. So, this way it is multiple valued concept. Now, let us see some idea about extending this idea. So, say RAM is honest, as we have discussed about it. Now, let us consider other two propositions P and Q, where the P is defined as Mary is efficient, and another proposition Q, it is defined as RAM is efficient. Now, this P being a proposition, let its truth value, that is denoted as Tp, and it is 0.8. The another proposition Q having truth value Tq and is denoted as 0.6. Now, these are the two propositions. Then we can see how the different operations are applicable to this proposition to give something more meaningful proposition. Now, P the Mary is efficient, we can have another proposition Mary is not efficient. This basically equivalent to P and Q are the two propositions as we have discussed here with this notation, and Mary is not efficient, this is the another proposition, and this proposition I can express as a P complement or not P, whatever it is. So, P complement. Then if Mary is efficient given this Tp, then the Tp of this T not P, this can be expressed by this formula 1 minus 2 Tp. That means, if Mary is efficient is a proposition, then Mary is not efficient, another proposition not P having the truth value 0.2. Now, if we say the another proposition in terms of P and Q, the given propositions, let the proposition be Mary is efficient and so is RAM. That means, it is Mary is efficient as well as RAM is efficient. So, in terms of P and Q, we can apply the AND operation, then we can obtain the truth values of this new proposition P and Q, and that can be obtained taking the minimum values of this one. So, it is basically 0.8 and 0.6. So, this is the results or resultant values of the new proposition P and Q, and truth value is 0.6. So, the different propositions and having the different proposition, the different operations that can be applied, those operations very much similar to the operation that is there in Boolean logic, that can be further extended to the multivariate logic that we have discussed using mean, using max and some mathematical relation, and then we can obtain the different propositions given the some elementary proposition or some basic proposition it is there. Now, again let us see. So, P and Q are the two propositions which is discussed here, and then we can have another proposition either Mary or RAM is efficient. So, if it is basically represent by means of the operation P or Q, that means Mary efficient or RAM is efficient, then truth value can be obtained using the max operation. Another example it is here, if Mary is efficient then so is RAM. So, the operation that is applicable to this fuzzy set is basically represented here. If Mary is efficient then so is RAM. So, we can represent this one, that means, if P is true then Q, and it is an implication. Now, truth value of this P implies Q can be obtained using this expression 1 minus Tp and Tq, and this value can be obtained as 0.6. That means, if Mary is efficient then so is RAM is another proposition whose truth value is this one. So, it is basically in terms of proposition, and using some proposition we can obtain some other proposition applying the operations on the multivalue logic that we have discussed. Now, we have learned about the fuzzy proposition and the crisp proposition. The fuzzy proposition basically is the multivariate logic proposition, where the crisp proposition is basically two valued logic proposition. So, this is the crisp value is also called the classical proposition, and the fuzzy proposition is a newly defined proposition for the fuzzy logic. Now, so here we can see in case of crisp proposition, this is require either true or false value to be returned. In case of fuzzy proposition, it can return any value in between 0 and 1, and this value basically signifying the degree of strength in the propositions, the resultant proposition. So, degree of truth of each fuzzy proposition is expressed in the range 0 to 1 both inclusive. So, this is the difference between the fuzzy proposition and crisp proposition. In case of crisp proposition, the result is always in terms of 0 and 1, and in case of fuzzy proposition it is in between any value 0 and 1 inclusive both the things. Now, we will come to the discussion about canonical representation of fuzzy proposition, because whenever we learn about fuzzy logic, we have to express some canonical way, the universal way. To do this thing, let us consider the X is a universe of discourse. This discourse consists of 5 persons, and we want to define one fuzzy proposition that intelligent. So, X is intelligent, like say Ram is honest with a different value. So, intelligent is a fuzzy concept or is a fuzzy linguistic, and any element X that can be belongs to this fuzzy set intelligent can be defined using this formula. This is the fuzzy set. So, now here you can check it. So, x1 is a one person, I say that he is intelligent with this degree 0.3. Similarly, x4 is another person, he will be treated as intelligent with degree 0.6. So, this is the fuzzy set defined over a discourse universe of discourse of 5 person, and their membership values is represented here. Now, having this representation, now I can say that we can define a fuzzy proposition in terms of this fuzzy sets like this: X is intelligent. Now, here X is basically can be qualified any one of this one, x1 or x2 or x3, this one. That means, then it will return, say suppose x is, for an example, x is x3, then what is the TP? So, is basically TP in case of x1 is intelligent. So, TP will give you, sorry, it is okay, TP x1 is intelligent, it will give you 0.3. Okay. So, this is the proposition that x1 is intelligent, and it basically gives the truth value that 0.3. Now, so this is the truth value if it is represented, then we can say this basically is a one way of representing a proposition, and this is called the canonical representation. So, canonical representation in general can be expressed like this form, where P is a proposition and V is an element which belongs to a fuzzy set F, and it gives basically a proposition that V is F, and then P gives the proposition. For example, F denotes a temperature and V is say 20 degree. So, 20 degree is, say F denotes a hot temperature. So, 20 degree is hot temperature, then it basically is a proposition, and the 20 degree is a hot temperature, whether it is with certain value, it can be any value in between 0 and 1, is basically gives the value of this proposition. So, this is the canonical representation of the fuzzy sets, and it is denoted by P as P, that is V is F. Now, this is basically other way P in terms of proposition in fuzzy logic, this P is called the predicate in terms of fuzzy set. So, P is the predicate and this is the proposition expression in the canonical form. So, where V is an element that takes value V from some universal or some universe of discourse the V, and F is basically a fuzzy sets defined over this universe of discourse V. So, this way we can have the fuzzy proposition or predicates we can say. Now, in other words, given a particular element V, this element belongs to F with membership grade mu F V. So, here the idea it is here we can see, we can elaborate this concept more meaningfully here, and see here as I told you, P is a proposition and it is denoted that V is F. That means, here F is a fuzzy set. If F is a fuzzy set, then definitely it will be defined by a membership function. This means that same membership function can be drawn by means of a graph. Now, here this is the graph of the fuzzy set F. That means, how the value of the membership function varies with different elements, and the different elements is defined over the discourse, universe of discourse, this is the V. Now, for any element that belongs to this fuzzy set F, let this element is V, then V is F, it basically gives the membership values for this V. So, it is basically mu F and V. Now, this is basically the TP, that means truth value of this proposition. So, it is basically we can write in another way, if P denotes a proposition such that V is F, then TP basically denotes the membership values for this proposition. So, for a given value V of variable belongs to set V, it is in proposition P with degree of value TP, it denotes the degree of that proposition, and this is the graphical interpretation of the fuzzy proposition there. And so, this is the proposition. Now, we have discussed many things so far. So, fuzzy element, the basic concept we have already discussed there. Now, fuzzy elements we have discussed, and then we have learned about the fuzzy sets. Fuzzy proposition just we have learned. In order to learn this fuzzy proposition, we have learned that the relations, that means fuzzy sets. So, these are the portion that we have learned so far. Now, our next learning objective is fuzzy implication. So, these things will be discussed in our next lecture. Thank you.